Okay, in this question, we need to find the integral of four functions here, and which is the antiderivative. The integral is an antiderivative, and we have four of them. The first one is this. Notice that what do you have here? This one is a power function or polynomial times exponential. And we know whenever we have polynomial times exponential in an integral, we do the killing game. And it's because 3x plus 2 is a polynomial that you can keep taking its derivatives to make it 0. So look what you will do. 3x plus 2, you'll say here I will take the derivative. So when I take derivative of 3x plus 2, I get 3, and I take one more derivative, I'll get 0. And on the other hand, you take here an integral of e to the negative 4x. If you take its integral, it will be minus 1 over 4 times the same. And if you take another integral, the same, but another negative 1 over 4, so it will be 1 over 16. Okay, and so now you will put arrows. Arrow going from the first one here to this one, and another one going like this. You will keep on going, of course, if you have more, but you stop at 0. When you have 0, you stop, and then you put a plus on the first, negative on the second, and so on. Always you start plus, minus, plus, minus. This is like a game that you play, and it will give you the integral easily. The method is integration by parts, but this is a way of looking at it and doing the question without writing u and v, du, dv. Just play this game and it will give you the answer. How do you write the answer now from this? You will say, therefore, the integral you asked me to do, 3x plus 2 times e to the negative 4x dx will be, and now you'll read it. So you'll say, this here times this with a plus sign. So if you multiply them, you get negative 1 over 4 times 3x plus 2 times e to the negative 4x. Perfect. And then the second thing is minus, and then 3 times this. So minus and 3 over 16 e to the negative 4x. So this is the answer, plus c, of course, because when you integrate, you always have constant of integration. You can simplify this by taking e as a common factor, of course. So here this will be e to the negative 4x outside, and inside I'll have minus 1 over 4 3x plus 2 minus 3 over 16. All of this plus c. Now what you can do is this also simplify it more. It could be that, as I told you, once you know the rule of integration, you can answer the question. But at the end, when you get the final answer, it's very important that you know how to simplify it to make it look more attractive. Okay, so this will be minus 3 over 4x, and then 2 times 1 over 4 is minus half, minus 3 over 16. Okay, and so this will be minus half minus 3 over 16 is minus 11 over 16. Because half is like, if you multiply by 8, it will be 8 over 16. And minus 8 minus 3 is minus 11. So minus 3 over 4x minus 11 over 16. You can just put it here and it becomes much nicer. Let's check that this answer is correct on the calculator. So, and we will see how our calculator, for example, would write the answer to this question. So let's do the integral of, and we have something times e to the power negative 4x, and here I have 3x plus 2. 3x plus 2 equals. Okay, so here they didn't take e to the negative 4x as a common factor, but you can see that it is, if you look here, 1 over 4, yeah. So compare this answer that we have here with the answer that you see on top. It is the same one, exactly. And you have minus 3 over 16 times e to the minus 4x as the second part. So you see, it is. They did not simplify it, but I'm telling you that it's good to learn how to simplify in case that one of the choices is the most simplified version of the answer. So always ask if there is a way to simplify things more. This requires just you have a good algebraic background. Okay, so now here and at the beginning of the semester, this course starts with a review of algebra to make sure that you remember these simple ideas, just to make the mathematical expression looks simpler than the way it is. In many cases, you can make it simpler. And now we have this integral. It has power function times logarithm. So now we have power times log. And if we have power times log in the formula sheet, we have it. This is not included in the formula sheet, but I told you that because it works for all powers except -1, it's good to remember this formula. Whenever you have a power times ln, then it will be add 1 to the power, divide by the new power, and then between parentheses, the ln minus 1 over the new power that you have here. It's just a very attractive formula for logarithm. And this is only when, this is for all a that is different from -1. So here it works, for example, for the one we have now, x to the 4 ln x dx. Yes, it works because the power is 4, not -1. But if the power is -1, it's just telling you that it's a special case, this one. Sometimes it can be written as this, ln x over x dx. You know that power -1 is the same as 1 over x. Yeah, so this is the only one that is a special case, when a is -1 and the answer becomes ln x all squared over 2. But in our case, nice, we have 4. So the answer will be what? Let's see. Let's take away the stuff here and see what our answer will be. If we have a equal 4, so the integral, let's put it here, the integral of x to the 4 ln of x dx. This is integration by parts, but because we did this formula so many times and we saw that there is a pattern, and actually there is a formula that covers all the cases, then we use it. So when you have x to the 4 times logarithm, you do x to the 5 over 5, just add 1 to the power, divide by the new power, and then in the parentheses you put ln x minus, and then 1 over 5. If this was x to the 6 over 6, this will be minus 1 over 6. So it's related to the power that you have. Okay, whatever number you have down here, you put it down there. Okay, plus c. But here we're not going to put plus c. You know why? Because it's a definite integral. So if you put plus c, you'll just be making it longer. It will cancel. So it's better just not to put plus c when you do a definite integral. So let's see how this will be. So this is x to the 5 over 5 into ln of x minus 1 over 5. This from the formula that we know gave me, and so it's from 1 to e. So first you put e. So first when we put e, we'll do it in red. Put e where x should be. And a common mistake, I will tell you, some students start by substituting this first. This is wrong. Don't substitute it first. This is the first one to be substituted. The one on top, the one in top of the integral is the first one you substitute. So it will be e to the 5 over 5 into ln of e, which is 1, minus 1 over 5. We know that ln e is 1. Okay, minus, and now you put 1 in the formula. So it will be 1 for x, of course. The 1, you'll put it now for x here and there. So it will be 1 over 5 into ln 1, which is 0. Log of 1 for any base is 0, minus 1 over 5. And let's simplify. Remember, ln e is 1 and ln 1 is 0. These you can also on your calculator do them if you forgot. So now this will be e to the 5 over 5 times 1 minus 1/5 is 4/5. minus, and now 0 minus 1 over 5, you see, it's negative 1 over 5 times 1 over 5, it will be negative 1 over 25. And there is a minus outside, so it will make this minus plus. So this becomes plus, to make sure, just that there was, 1 minus 1 over 5 is 4 over 5, right? Then plus 1 over 25. So it's 4e to the 5, 4e to the 5 over 25 plus 1 over 25. So actually you can combine them. 1, or let's put e first. 4e to the 5 plus 1 all divided by 25. This is the answer. Of course, this here is a number. Just you need to find it as a decimal. So let's check on the calculator. I'll put it here, and then the question was this one. Now I'll put it inside the calculator. This is a regular definite integral, so you use just the regular thing. You can do it actually this on your calculator. The Casio calculator can do this integral. And you put from 1 to e, x to the 4 to the power 4 times ln x equals, let's see. So they put it as a decimal, but I'll change it to a fraction to see what it looks like. Yeah, 1 over 25, let's see, is the same. 1 over 25 for e to the 5 plus 1. Perfect. With a happy face. Correct. Okay, so we will go now to the third part C. And in this one, it's telling us integrate between 1 and a without telling us what is a. So they want us to find this integral in terms of a. Otherwise, they would give you what a is. They just told you that it's more than 1. Because we're starting the integral from 1, this number usually is a bigger number than the one below it. So from 1 to a, where a is, it could be 2, could be 7, but any number bigger than 1. Perfect. So what I'll do now is evaluate this integral. So before you evaluate, you look at the inside. Notice that this is the same as 4 minus 1 over, now x times radical x is x to the half. And this will be 4 minus 1 over x to the, this is like power 1 and power half. When you multiply them, you add 1 plus half, which is 3 over 2. And so finally, just put x up, so it's minus x to the negative 3 over 2. This one. Here is the same as our integrand, but we wrote it in an easier way to integrate. So you'll say this is equal the integral from 1 to a of 4 minus x to the negative 3 over 2 dx. This way you can integrate faster. This will be 4x minus, and now a power function. You add 1 to this power, so add 1 to negative 3 over 2, that will be negative half, divided by the new power, negative half. No plus c because it's a definite integral here, so you go from 1 to a. If you do plus c, by the way, you will first put a and you'll get the c, minus, you'll put 1 and get the c again, and when you subtract, it will cancel itself. So better not to put the c. It's just better. And just simplify this further. 4x, and then x to the negative half is 1 over root x, and minus minus is plus. So this will be plus 2 divided by root x. Just from knowing properties of powers. So this is from 1 to a, and now put the a inside. So this will be 4a plus 2 over radical a when you replace a, minus, and now you replace 1. Always there is minus, and then what happens when you replace 1 for x? Put, it will be 4 times 1 plus 2 over radical 1, so 2. And finally, this becomes 4a plus 2 over radical a minus 6. Here, in terms of a, this is the integral. Let's check. Actually, this calculator can also enable you to check your answer for this one. So I'm going to write the integral as it is. So integral between 1 and a, and so a is here. So you'll put 4 minus 1 over, or even, yeah, I can put it as it's written, 1 over x radical x, or x here to the power 3 over 2. 3 divided by 2. Okay, so let's see, equal. Let's see the answer. They kind of took 2 outside, yeah, 2, and then inside I'll get 2a, yeah, plus 1 over radical a minus 3 from this, which is exactly what's written here. Happy face, we got the right answer. Okay, good. Now, last part, I'll erase all to go to the last part, is this one. And this one is also a nice question. Notice, logarithm always needs to be simplified before you start. I told you this several times in many questions in this review. So first you say, logarithm, this is the product of two things. So it's ln of pi cube plus ln of x squared, which is, now ln of pi cube, keep it as ln of pi cubed. It's just a number. This is a constant. Plus ln x squared is 2 ln x. Whenever you have something that contains x, simplify it. This one, even though you can bring the 3 down, but it's not necessary to do it for pi. Just keep it like this, okay? Because it's a constant. And now, therefore, our integral becomes the integral of ln of pi cube plus 2 ln x dx. See, you just simplified the inside and made it like this. And this is much simpler because we know that ln of pi cube, this is a constant. So integrate a constant is just the constant times x. So this is ln pi cube times x plus the integral of 2 ln x. Remember the integral of ln. So first I want to remind you, the integral of ln x dx is the same as integral x to the power 0 ln x dx. And from the formula sheet, this is telling you this will be x to the 1 over 1 into ln x minus 1 over 1. When I said from the formula sheet, I'm talking about the formula sheet that I have here. This will not be given to you in the final, this specific rule. You just remember it. This rule is given, of course, the regular power rule, but this is a special one that if you notice it and you remember it, you'll make your life easier, because this formula will always be correct as long as the power of a, the power of x here is not negative 1. So if this a is 0, it's also okay. X to the power 0 is 1. So you get just ln x. And you just write it here. So plus 2, and then the integral of ln x is x ln x minus x. Then plus c. And now I will continue it here. So it will be ln pi cube x, I'm just simplifying now, plus 2x ln x minus 2x plus c. And notice, this 2, I'm going to put it up here for the square in order to write my final answer in the same way that the function was given. You will see, you'll appreciate it more when your final answer, you group it again to write it in the same way that it was given. So notice here, x appears here and here. I take it as a common factor. Inside I will have ln pi cube plus 2 ln x. That is ln of x squared. Yes, and then minus 2x plus c. And so these combine them, it will be ln of pi cube x squared. Because you're done already with the integral, so put it back as it was given. So this becomes x ln of pi cube x squared minus 2x plus c. And actually x again is a common factor. And you can have ln inside ln of pi cube x squared minus 2 plus c. This probably is the simplest form. But once you reached even here, you were done already. I mean, you got the formula. All what we did here was simplification. Okay, so let's check that this is the correct answer. I'll put the calculator here and we will write this integral. Okay, so it is the integral of ln of pi cube, so pi is here to the power 3 times x squared, so x is here squared, and now we close it, equals. So you see x times ln, it's exactly what we got. X outside, so let me use another color. Yeah, x is outside like you see in the formula here, and then inside ln pi cube x squared minus 2. Perfect. And of course you put plus c because it was an indefinite integral, so you need to add a constant at the end. Our calculator doesn't put plus c. Okay, and I will stop here.